Okay, so let's start. Hey everybody, my name is Alonso. I'm a software developer in the Rails team. Today I'm going to talk a little bit about conversational bots and natural language understanding. So I've been working with bots 3 years now, and I find that there is such a potential on changing the way we interact with systems. Like I strongly believe that bots have the potential of replacing or enhancing web. I know that sounds crazy, but so it's way easier for you to say, okay, Google, do this instead of opening your phone, unlocking, going into the website, navigating through. So in this talk, I'm going to talk a little bit more about this idea and how we're going to run through a demo and then look at how the demo is implemented and what the possibilities are, if crazy, I guess. So let's start with the idea versus an actual implementation. So we can do a lot of things, but sometimes they don't make sense, or it's better to keep it simple. So this idea started with the boom of, oh, we can move everything to the website or to the software, and now we have a massive website with a million options that I just want to do this, but you need to spend so much cognitive load navigating through everything that is on the page and then figuring out how to actually implement this or whatever you need to do. So is it possible to actually make this simpler? Because we actually have experienced this in the past with Google, which is, what do you want me to look? And that's it. So simple, so clean, right? So trying trying to copy a little bit this idea where now everything can be implemented in a chatbot. So you can put there whatever you want the system to do, and it will do it, right? It sounds great on experience. Spoiler alert, it's harder than it looks like, but for do POCs and demos, it's great because you know what people are going to say. So with that, let's start with the demo. Yay! So in this demo, so for those who don't know, I work in the rate team. Hold on, this is harder than it looks. Yeah. Okay, so for those who don't know, I work in a race team, and we now are a full stack team. So we own end to end from the front end to the back end. So it will give you a lot of opportunity to implement the whole thing. We don't need to actually implement functionality, guess what the functionality is going to be used, and then the front end is going to try to implement what the customer wants and figure it out that the backend team didn't implement it the way they wanted to, and then now we have a pilot of the cross-functional team. Yeah. So with that in mind, and my experience with conversational bots, we could even change the website to be just a chatbot. So in this case, imagine that your customer wants to create a policy. Create a policy. And then it's going to ask. Okay, so here in the left side, you can see this is implemented on Lex, Amazon Lex. So you have all the things that needs for that to work. I'm gonna get into that later, so don't focus too much into that. So let's say 9 a.m. Oh, no. No, a.m. So when the set end at 5 p.m. How much is that going to cost per hour? The website understood what the bot was trying to do, and it was, now you have it. So this is just another way of implementing the thing. I'm not saying that, oh, now let's replace all the website with a chatbot and that's it, because people don't know how to use chatbots. We need to train them first how to use it, and so it's not the silver bullet for all your problems. So another use case could be delete the first one. Oh no, sorry, that's the third. Add another. Period. From 7 a.m. to 9 a.m. To prepare. Okay, so this is just another, and finally delete the first one. We'll go and delete the 9 to 7. This is just an example of how chatbots could be used. So now let's dig in a little bit into what is actually behind the bot. What is the bot? So the bot is, so the structure of the bot, it starts with some actions or intents. So basically what the customer needs to do. So features in this case. And those are like, I want to create a policy. And then that policy will have some parameters of slots. In this case, when it starts, when it ends, what's the cost, whatever you want. Those could be optional or mandatory. Then you have utterances. Oh, yeah. So you can use this as like in a sentence, and then the first one. That first one is the parameter that is going to be used. That is done automatically by the service, in this case, Lex. And okay, and then finally, the integration of fulfillment is basically a REST API request with all the things that have happened. So on top of that, bots are smarter than that, or not smarter, are built in a platform. Like for example, if you're using Alexa or Google, they already have payment. So you don't need to do the payment. You ask the middleware, in this case, Google or Alexa, hey, I want to charge this much, go nuts. And then Alexa will actually fulfill the payment. It will ask the customer what credit card do you want to use, what address do you want to use, and then the bot is only going to receive, this is the confirmation number. So in that end, there are multiple other functionality, like keep in mind that bots is just the natural language understanding. So understanding, hey, I want to do this, translating that into an action and parsing the parameters in that sentence. So on top of that, that is running somewhere. So it could be running on a cell phone or IVR. It could be running on a device. Depending on what you're running, you might have more or less features. Like if you are, for example, on Google Home, you might start recording or doing things like, yeah. So in that end, let's go back into Lex. So this is actually the Lex UI. So we can see on the left, we have the intents. In this case, it's just create and delete. Then the intents has the utterances in the middle. So you have add period from A to B, delete, or not delete, no, create from date, and you can build your own utterances. Lex will create a machine learning model out of this, and will fulfill the slots. The slots are the parameters. The parameters to be required or optional, and in each of them, you can ask follow-up questions if they are not provided. Like in our case, is the how much is that going to cost? So I don't have utterances to fulfill that right away. So it's gonna ask that. And when all the slots are filled, it's going to execute the fulfillment on the Lambda in this case. So let's now go into the demo and what is actually happening on that website, because there are a lot of things happening on that website. So first we have the user with the web, and they request, hey, I want to create a policy. So they ask the bot. and then the bot will keep asking or answering questions until they got into Lambda for the fulfillment. And then, so in this case, we could use this as a request response. So the web is going to know what the response of the Lambda was. However, it's not as flexible because in this case, Lambda needs to know everything about the whole interaction to fulfill that in advance. Another requirement is like speed. For example, Google Home and Alexa are not going to let you run for more than 8 seconds. At 8 seconds, it's going to time out, right? But there are some use cases where you actually need like 30 seconds or something, or execute a song. It's going to take minutes. So that's why they use IoT, which is basically pop subscribe service. So it's one-way communication. The web is telling the bot what to do, and the Lambda is publishing something into IoT, and then the web is actually listening for whatever the action was and accordingly. So on top of that, this opens a lot of functionalities. Like for example, imagine that now you have 2 users and 2 users want to have the same status, or it could be even better. Like imagine that you are doing a multiplayer game. So now with this, you can have the 2 websites working together. So imagine in this case, we have 2 screens. We could have one website managing the 2 screens together, and the system knows which one it is. So yeah, there are a lot of games and things like that. Like in PS, you have a game that is going to start a web server, and then you use your phone to actually answer the phone. So it opens the doors to a lot of possible interactions. So on top of that, it's not only web. This interaction could have started by the phone. So you can actually go, hey, I want to get a policy from this to this and that to that. But the website is still going to capture that. Or you might update the website that is on a space, and hey, I did that. In these cases, policies is quite constrained, but in other use cases, it could be useful. So on top of that, all these interactions that are 3 different, it could be only one person using all the devices at the same time for different actions. Like you might use the screen for the screen, you might use the phone for the voice, and the keyboard in another computer for the typing. So with this in mind, I'm gonna start going a little bit. Do you have any questions, by the way? Because okay, so with that, I'm going to dip a little bit deeper into IoT. So how can we use the IoT from AWS? So the first is that they provide an SDK. Of course they do. So they have actually 2 SDKs. They have one called IoT data and device. So the main difference, or the difference between them, is that one is HTTP, so it means that it's request, response, and that's it. In the pop subscribe world, it's only request. Response is okay, got it. But you don't know if the other end, whatever is in the other end, actually make use of it. And then you have the device, and the device use MQTT, which is a light protocol for IoT devices. So keep in mind that this protocol was meant for microcontrollers. So it's extremely low in requirements. And then you have the embedded version, which is using WebSocket, but transferring MQTT through WebSocket. So it's like the hack for the web. Okay, and then from the IoT, you can execute a lot of actions. I didn't know this many actions, but you can transfer to CloudWatch, Dynamo, Elasticsearch, Firehose, HTTP, Kinesis, and so on. So this is just configuration. So when this event happen, store that in S3. When this event happen, store that in Kinesis. And you can filter by the subscription string. So the IoT data is quite straightforward. It's only put, it's not subscribe. The device is pop and subscribe. So I'm gonna go into the device. So AWS implemented quite handy feature, which is called shadow device. So what problem are they trying to solve? So imagine that you are on your home and you find a sword, right? So in the IoT world, things are going to be asking, hey, what is your state? What is your state? What is your state? Instead, here it's going to tell you, hey, I find a sword. Hey, I did this. Hey, I did this. But there is a problem. There is no something that I can ask, what is your state? So then they created this service where all the updates are stored, right? So that so now instead of asking the device, hey, what is your state? You can get the latest state from the internet. However, with this in mind, what happens if you are not able to update AWS? So what happens is that you get the source, now you want to update, you can, or the other way around. People want to know what your state is and nobody knows. So if we go back and we use a shadow device, so now, okay, we got the source, we are going to put a shadow into AWS. So instead of user asking the device, hey, what is your state? They are going to get the latest state from AWS. So this is not free, of course. You have other vulnerabilities, like if you go offline and then you lose the source, AWS will think that you still have the source. But so going back, keep in mind that, but at least users will know your latest state. So any questions about this? Nope. Okay, so now let's start with Lambda. So Lambda, they have two main type of events. They have synchronous events and asynchronous events. So synchronous event are requests is going to wait for whatever is there, and then it's going to respond. So you can see why this is useful. Like for example, Kinesis trigger is going to wait until all the records are processed. If one fails, Kinesis is not going to move forward. It's going to hold. Same with API Gateway or Elastic Application Load Balancer. You want to know what the result is to publish that to the actual website. So all the possible triggers, I don't know, this is not full, this is just a summary, are all the possible triggers that can execute Lambda synchronously. So the other possible use is asynchronous. As everybody knows, asynchronous is one way only, so you get the request and forget. You don't wait for it. But Lambda comes with a set of retries by default. So every single asynchronous event is going to be tried 3 times, so once per minute. I'm pretty sure it's 1 per minute. And then if the 3 times fail, it's going to put it into the dead letter queue and move on. So some of the triggers that we execute events asynchronously are S3, SDN, IoT, CloudFormation, CloudWatch, email, and the CLI. So yeah, any questions about those types of events in Lambda? Awesome. So finally, I'm going to start with what happened when you try to invoke a Lambda function. So this is just magic, right? We execute a trigger, something happened. But what is actually happening? What is this cold start? Why things take so long? Is everything up and ready, or what's actually going on? So the first thing is that when you invoke Lambda, Lambda will check that you are authorized to execute that Lambda. Then we'll check on the instance pool, and we'll check if there is any instance of this Lambda and this version available in the pool. So this is what is meant to be warm, when there doesn't need to be an instantiation or of a new instance of the same Lambda. So this is quite fast. And then you have if if all the instances are busy, then they are going to create a new one. This is where 10 seconds can take to create the VPC on our private network and then put it into the pool and then get the request. That's what actually behind that latency. So one thing to keep in mind here that I don't know if many people know that Lambda is HTTP. So, and it's public. So anywhere in the world, I can try to execute our production Lambdas. It's not through the VPN, it's public. The only thing that is private is the network adapter on the Lambda itself. But where Lambda is running, all the managing, everything about Lambda is public accessible. It's a managed service. And with that, do you guys have any questions?